Imagine strapping like a SpaceX rocket engine to a rusty 10-speed bicycle.
Oh, that sounds like a disaster.
Right. I mean, the raw speed is incredible, but it completely outpaces the structural integrity of the bike, and you inevitably end up with a spectacular crash.
Yeah, the wheels just fly right off.
Exactly. And if you're listening to this and you've ever had an AI write code for you, well, you know that intoxicating speed. Welcome to today's deep dive.
We've got a really fascinating 2026 startup analysis document today. It covers 206 innovation, Syntropic systems, and the ODI mesh framework.
Right. So our mission today is to figure out why this hyperfast AI coding is actually causing massive structural chaos and how a new operating system is trying to fix it.
Yeah.
Okay, let's unpack this. Giving your developers frontier AI coding tools right now is basically leading to massive delivery failures.
Because the code base just drifts totally away from your roadmaps and your security. Yeah. That is the core paradox we're facing.
Right.
The code is flying out faster than the organization can secure it or route it or, even understand it. The document calls this organizational entropy, which is essentially just systemic chaos.
So if managing the code in a vacuum doesn't work, how does Syntropic actually keep the bicycle intact? Like, how do they steer the rocket?
Well, they use a concept called the four-graph foundation. Basically, they map the entire organization simultaneously. You have the org graph for people and expertise, and the code graph for architecture.
And then there's the plan graph for roadmaps, like Jira.
Exactly, plus the policy graph for governance. But instead of just tracking these in silos, like most companies do, the system cross-references them in real time.
Okay, so if a developer uses AI to write code that violates a security rule on a policy graph, the system just catches it.
Yeah, or if it strays from the Jira roadmap on the plan graph, the mesh catches the misalignment and pauses the deployment before anything actually breaks.
Oh, wow, that makes perfect sense. It forces the rocket to actually steer instead of just blasting off in a random direction.
Right, and what's fascinating here is how this system spots hidden ripples across those different graphs.
What do you mean by hidden ripples?
Well, the telemetry in our source document showed a localized failing pull request on an API gateway. Because the mesh cross-references everything, it instantly flagged a multi-million-dollar data platform upgrade on the company's roadmap as severely at risk.
Wait, just from that one tiny code error?
Yes, just from that one pull request, it saw the whole chain reaction.
Okay, wait, I have to push back on this. If an AI is actively hovering over every single employee's Jira tickets and tracking their personal expertise and reading their code snippets, isn't that a chief information security officer's absolute worst nightmare?
Oh, 100%.
I mean, that sounds like a massive corporate data privacy breach just waiting to happen.
That privacy fear is very real. It's actually the exact panic that caused the Atlassian Rovo controversy back in August of 2026.
Oh, right, the opt-out by default thing.
Exactly. They rolled out AI data harvesting that sucked up internal strategic documents to train models, and enterprise executives understandably panicked. You simply can't have your unreleased product roadmap becoming part of a public AI's brain.
Right, so how does Syntropic get around that without sacrificing the AI's intelligence? Like, how do they use the big models safely?
They built this ingenious internal trust tier. They call it a synthetic reasoning packet, or SRP. When the mesh detects a complex structural problem, it forcefully scrubs all the proprietary markers.
Like IP addresses and cryptographic credentials.
Yeah, and specific variable names. It packages up the sterile geometry of the problem completely detached from the sensitive data. Then it routes only that abstract packet to external models like GPT-4o or Claude 3.5 to actually solve.
Okay, here's where it gets really interesting. So it is basically like sending a top-tier surgeon your medical x-rays, but your name, your face, and your hospital room number are entirely blurred out.
That is a perfect way to look at it. The surgeon can look at the structure, tell you exactly how to fix the broken bone, and send the instructions back without ever knowing who you are.
And then the system safely maps the abstract solution back onto your private variables internally. That is brilliant.
It is. And to build a system that translates chaotic corporate workflows into sterile mathematical order, you would probably assume the founder comes from standard HR tech.
But he doesn't, right? Looking at Timothy J. Dillon's background, he actually built a $3 billion patent portfolio in high-frequency live sports microbetting, which is wild.
It is wild, but it makes sense. That industry requires systems that can ingest chaotic, real-time game moments and process them instantly. But his theoretical work goes even deeper.
Yeah, didn't he tackle the class conjecture?
He did. It's a famously unsolvable math problem about how chaotic numbers eventually loop back into a predictable sequence. He theoretically proved it using a framework called compressed odd dynamics.
So he is essentially a master at finding hidden, predictable patterns inside total chaos.
Exactly. If we connect this to the bigger picture, Dylan is taking the exact same high-level mathematics used to collapse unpredictable mathematical orbits into stable cycles.
Which is a process called syntropy, right?
Right, and he's applying it to rescue messy, decentralized engineering teams.
So what does this all mean for you as a listener? Well, it means the future of AI isn't just about completing individual tasks faster.
Precisely. It is about underlying systems safely and silently orchestrating the messy, complicated reality of human collaboration.
Right. We are finally building a structurally sound enterprise bicycle that can actually handle the AI rocket engine. But it does leave you with one lingering, slightly terrifying question to mull over.
Oh, what's that?
Well, if this ODI mesh can perfectly map, govern, and optimize the people, the code, the plans, and the policies of an entire enterprise, how long until the software realizes it can run the company much more efficiently without the human executives who purchased it?